In this video, we're going to make a flow chart for writing the names or formulas for ionic compounds. So, well, before we even get to the point where we're talking about ionic, how you can determine if a compound is ionic or if it's a covalent molecule is by asking yourself the question, is a metal or ammonium the ion present? If a metal or ammonium ion is present, you have an ionic compound. If it's not, you have a covalent molecule, which is comprised of only two nonmetals. In that case, you'd use prefixes, and I'm going to tell you that that's not on the test. Since we're looking only at ionic compounds, there are a few other questions you could ask yourself. One, are only two elements present? If you have only two elements present, that's called a binary, bi meaning two, compound. And those are pretty simple. If you have more than two elements present, then you have a ternary compound, which means it contains a polyatomic ion. So if you see three or more elements in the formula, you have a polyatomic ion. And if you're given the name and you see either ate or ite, it's got a polyatomic ion in it. The exceptions to those, there are three that you need to know that end in IDE, which is common for binary compounds and not polyatomic ions, but those are hydroxide, cyanide, and peroxide. If it's not one of those three and it ends in ide, it's going to be a binary compound. So binary compounds are just a basic combination between a metal and a nonmetal, and if you're given the name, in order to get the formula, what you do is you look up what the charges would be on the periodic table. So calcium's in group 2. For this one, calcium fluoride, given that name. So it's going to have a positive 2 charge. Fluoride, being a halogen, has a negative 1 charge. So you know that when ionic compounds form, they do so in a way where the ions form in a ratio where the charges cancel each other out, and you end up with no net charge for the compound. In order to do that, you'd have 2 fluorides for every calcium, and you'd have a formula CaF2. If you're given the name, it's really simple to write the names for these. You just write the name of the metal, then the nonmetal, and then ide. So like sodium chloride. Typically it's just one syllable before changing the ending with these. If you have a ternary compound, you just say the name of the metal and then the name of the polyatomic ion. Again, the exception to this, if it's ammonium, ammonium is the only positive polyatomic ion. But name of the metal, then the polyatomic ion, and you don't change the ending to IDE, you just say what it is. So here you have magnesium combined with nitrate, magnesium nitrate. Again, you don't use prefixes when we're talking about ionic compounds. So it's not magnesium dinitrate, it's just magnesium nitrate. Now, if you're given the name and you need to get to the formula, what you would do is you have to look at the charges, just like you did on the binary compounds, and say, so if you have aluminum sulfate, aluminum always has a positive 3 charge, sulfate has a negative 2 charge, you're responsible for knowing that. So the best ratio you can get where they combine to get no charge is when you have 2 aluminums giving a total of positive 6, and then 3 sulfates, which give you a total of negative 6, canceling each other out to no charge. So your formula would be Al2SO4 in parentheses 3. Anytime you want to say you have more than one of a polyatomic ion, you have to use parentheses to indicate that. Don't just distribute how many there are. You wouldn't say S3O12 because that thing doesn't exist. Now, the last question you're going to ask yourself that adds a little bit of complexity to this is it transition or poor metal present? So the things under the staircase on the periodic table or something in the D block, with 3 exceptions being aluminum, zinc, or silver. Aluminum's always +3, so it doesn't need a Roman numeral. Zinc's always +2, silver's always +1. So we use a Roman numeral to indicate the charge of the metal. So if you were given the name iron 3 carbonate, what this 3 tells you is that the iron is going to be positive 3. So when you're figuring out what the formula would be, you account for that. Carbonate's always negative 2. If the iron's positive 3, the lowest common number you can get those two values to is 6. So I need 2 irons to give me a total of +6 and 3 carbonates to give me negative 6 to balance out the charges, and you would say that the formula is Fe2CO33. So when you're given the name, you need to have enough information to be able to write a formula from it. If you weren't given that 3, iron can be either +2 or +3. You'd get a different formula if it was a different charge, so you need that information. Now, a little trickier is going the other way. Going from the formula to the name, well, given this one, titanium and oxygen, or oxide, you know it's a transition metal, so you know you're going to need a Roman numeral. So figuring out what that is, you have to get it so that they add up to no charge. So if you have 2 oxides and each has a negative 2 charge, and you only have 1 titanium in the compound, the titanium has to balance out the oxide's charge. So oxide gives a total of -4, so that individual titanium atom or ion must be +4. So you would write the Roman numeral IV. So that's the flow chart to use when writing names or formulas for ionic compounds. Use this to kind of guide you as you're working through problems if you're getting stuck.